Thank you guys for tuning in. This is part 2 of our 4-part webinar series, where we are going to be talking about indoor positioning and what you need to know. A couple of housekeeping things before we hop into the presentation. I do have everybody muted. We have done webinars in the past where we've gotten a lot of background noise in the recordings. I don't think anybody wants that. So I do have everybody muted, and we are recording. So like I said, if you want a copy of this, feel free to request one. Other housekeeping, we will be doing a Q&A session at the end, and we will be doing that through chat, through Zoom chat. So we have a couple people on the Apptricity side who will help moderate that with me. But if you have questions as we go along, feel free to hold on to them until we get to the Q&A session, and then we'll do our best to answer as many of those as possible. If your questions are not answered, reach out to myself, reach out to Susan. We'll make sure that we address whatever specific questions you have around IPS. Aside from that, that's all the real housekeeping type stuff. So let's dive right in. So just a bit of an overview about the webinar. Like I mentioned, this is part 2 of our 4-part webinar series. Part 1 was 2 weeks ago. If you'd like a copy of that, you can also request that as well. I think we'll have that up on our YouTube at some point for people to check out. So if you don't want to get a personal copy, that should be up on YouTube at some point. But just a quick overview about the webinar. I'll give an introduction to myself and our company. I'll review part 1 of the webinar series and talk a little bit about the future webinars that are coming up. And then we'll be doing our indoor positioning, everything you need to know. We'll have a Q&A, and then we will close. So that will be the format for today's session. So brief introductions. For those of you who were on last week, you've already heard this. I just recycled the slide from last week just to keep things familiar. But my name is Christian Garcia. I'm a product manager here at Apptricity, and I work on our supply chain software suite. Basically, that includes asset management, inventory management, and field services. And so I've been with the company for 7 years. I work on developing the feature sets for our products. And we've been, Apptricity, in the supply chain business for over 20 years. We work in both the commercial and government sector. We have clients that include Verizon and Brinks and the U.S. Army. We also work with various branches of the U.S. Air Force as well. So we have a commercial side and a government side, but really key takeaway is that we've been in this industry for a long time, and we want to use this webinar series as a way to share some of our knowledge that we've gained in the supply chain world with you guys, and some of the solutions that you can implement to help optimize your supply chain. So a little bit about the webinar series. If you missed part 1, we talked a little bit about tagging technologies for your supply chain. So the different tags that you can use to track and manage, assets and inventory across your supply chain. Session 2, which is today, we're talking about indoor positioning. Session 3, which will be August 10th, is indoor positioning. It'll be an industry spotlight. We're still waiting to figure out what industries we want to focus on. So your feedback will be vital in terms of what industries we determine we want to focus on for that session. And then session 4 will essentially be a wrap up, just making sense of the different supply chain tracking technologies, how everything fits together, and how you can use it, what an implementation plan looks like, things of that nature. So each of those sessions are on a Wednesday at 10:30 a.m. Central. We have kept that time period consistent so that there's no confusion among the different types or the different times, starting times and dates and things of that nature. So that's our webinar series. We are on part 2. So without further ado, let's just hop right in. We're running a little bit short on time, so we'll dive right into the bulk of the session. Indoor positioning. So what is it? Let's just start at the very, very top, right? An indoor positioning system, so we're going to abbreviate that as IPS, is used to provide location information inside of an area like a building, a warehouse, it could be a storehouse, or really anything that's enclosed, right? Now, I'm going to refer to it as an IPS system. If you're familiar with ATM, it stands for automated transaction machine. So if you call it an ATM machine, you're really saying an automated transaction machine. I'm going to be using IPS system. It's the same concept. I know that I'm saying indoor positioning system, but it's just ingrained in my mind. So you can correct me if you want in the chat, but that's how I'll be referring to it. It's an IPS system. I might use IPS solution as well, because that actually makes sense. So the best way that I think to understand IPS is to first understand GPS. I consider them to be brothers because they operate with a lot of the same concepts, right? So a GPS system, a global positioning system, functions in a very similar way. But this technology is obviously used for outdoor tracking. And I believe that understanding GPS really helps give us a solid foundation for understanding IPS. So that's where we're going to start today is what is GPS? Now, you may know this already. I think we all use GPS to some extent. I use it, in my commuting. I use it to, to call an Uber when I'm at the airport or if I'm tracking my DoorDash driver. GPS is something we understand, right? But basically, GPS is used to provide location information for devices with a GPS antenna. Our smartphones have them. Our cars may have them. Anything with a GPS antenna that can communicate with satellites that are orbiting the globe for location information. So basically, one of the things that I actually had to correct myself on not too long ago was the difference between triangulation and trilateration. Because I think a lot of people say, oh, well, GPS works through triangulation. And that's not true. GPS works through trilateration. And the difference is that trilateration is used to calculate distance, while triangulation is used to calculate angles. Now, at Uptricity, we've got some very bright people who work on our IPS system who are way better at understanding trigonometry than I am. I'm not a math whiz. I never was. I would never pretend to be. But basically, I think that's okay because I don't think we need to get too deep into the math of it all. But basically, what trilateration does, if you look at it on a 2D plane, if I have two static points, that third point, let's say that the two static points are satellites, and the third point is my smartphone. As my smartphone moves around, if I know the distance between the two static points, I can always calculate the distance between that third point that's moving around, right? Now, obviously, when we start talking about GPS, we're working on the 3D plane, and that's where we have our diagram here. So basically, if you think of a satellite, now obviously this isn't a 3D diagram, but I think you'll get the point. Satellites, you draw a radius around the satellite, and that's essentially its read range, right? The more satellites that read a tag, the better the location accuracy that you get. So you'll see, imagine I had two satellites reading that tag. The zone in which that tag could be, or in this case, let's call it a smartphone, is broader. But as I add more satellites to that read, the location accuracy starts to shrink, right? I get a more precise reading on where that is. And so obviously this is a 2D diagram, but that's how GPS works for the globe and for our navigation systems. And this is very similar to how IPS works. So what is IPS, right? It's a system that uses trilateration in the same way that GPS, but it does it in a localized mesh. So I traveled not too long ago, and for those of you who have traveled often or you've been to the airport and you're calling an Uber, say you're in the middle of the airport, maybe you're at baggage claim or you're just getting off the plane and you're trying to call your Uber because you want to get, you don't want to wait in the line for 20 minutes. You want to be there when you walk out. As you're in the middle of the airport and you're on your phone, you're looking at Uber, you'll notice that your GPS dot is moving around, right? And the reason for this is because satellites that are orbiting the globe cannot accurately read your position because the signal is weak, whether it's the concrete, the building, any of the things that are impeding the signal coming into your device. Now, we talked a little bit about this last week when we talked about tagging technologies, but impedance is a major factor in terms of determining scan accuracy or location accuracy. And so a lot of people ask, well, why can't I just use GPS tags indoors? Well, the reason for that is because there's so much interference with that signal that data you get for GPS is not, it could be useful depending on how big of a margin of error you're willing to accept. And for most people, when it comes to indoor, you're not willing to accept, a ton of feet, hundreds of feet or whatever the case may be. I find this often in our building. If I'm testing our GPS solutions with Uptricity If I'm in the middle of our building, I'm not going to get good readings. If I get closer to the window, it'll be better, but it still won't be great. And so this is why we use IPS instead of GPS for indoor. And these technologies operate almost exactly the same. It uses trilateration. I have static points, static readers in a building. I know the distance between those readers. And so as items move across the floor, I'm using trilateration to determine the distance between those readers, and therefore I can determine where it is on a floor map. So we're creating a localized mesh. We're providing location data accuracy up to 3 meters. Now, 3 meters is kind of the standard that we like to promote at Aptricity, but the technology is advancing rapidly, right? We could probably debate on whether or not this is cutting edge or bleeding edge technology. I'll leave that up to people who care more about that than I do. But the fact of the matter is that this is a technology that works and it's constantly improving. So in the example that we use for GPS, the more satellites that read a tag, the better the location accuracy is. Same concept applies for IPS. If I have multiple fixed readers that are reading a tag, I can better dictate where the location of that tag is. If I'm only getting it from 2, remember we have our circles that we draw around our scanners. It could be in any of the zone that's shared between those 2 readers. As I introduce more readers, it can only be within the shared zone of all of the readers. So your margins start to shrink, right? And so this is what we call establishing a mesh, right? So location data accuracy, as Bluetooth technology continues to advance, as the algorithms continue to get fine-tuned, that location accuracy is going to continue to shrink to the point where we will know the exact position. Now you may be asking, okay, well, what does that mean? What is that data? How is it contextualized? And how can I view that data? And this is where we get into the components of IPS, right? The third component on this list is the floor map. Oh, my microphone just came off. Give me 1 second. These are the type of technical problems that you never complain for. All right, that should be fine. You're not looking at me anyway. You're probably looking at the slides. All right, so back to the components of IPS. So the floor map, this is really where we display the location information for the tags, right? This could be an uploaded blueprint of your building. This could be a PNG, it could be a JPEG. We've gone as far as AutoCAD, and basically what we can do in our system is we can convert AutoCAD to what's called GeoJSON so that we can display it on a map, right? But basically, on the floor map, we're defining where our fixed readers are, and basically that's equivalent to an XY coordinate. So think about a JPEG image of your floor plan, right? If I'm putting points on there that represent fixed readers, that will have an XY value on the image, but we need a way to convert that into real world measurements, feet, meters, whatever the case may be. And so as we upload the floor map, we're taking that floor map, and ideally those floor maps would have a scale, the same way that a map would have a scale, right? Where maybe 2 inches equals however many feet, right? I don't know the exact measurements for that and what's standard for that, but the floor map is where we view the information, right? So in our legacy 7.5 product where we first did IPS, this is just a 2D image that you pull up and you can view the assets on the floor map, and it refreshes and you can see the movement as it happens. In our new 8.0 product, this is ingrained directly into the map. So I can go from a location search, I can select the floor and immediately see that map in geolocational fashion, right? So that's where we're talking about GeoJSON. I don't want to go too deep into the technical, blurbs, but that's the format that the data comes in. The other components of IPS, we have Bluetooth low energy beacons, right? So these are what you would affix to any inventory assets, whatever it is you want to track. That's what you would use. Now, again, if you didn't make it to last week's, or not last week's, but the last webinar that we did, Bluetooth beacons, they are an active tag. They basically just broadcast their information. So basically as the tags are moving around the floor, they're broadcasting, and then the readers are picking it up, right? Second part of IPS, fixed readers, right? So we are establishing static readers across the building, across the floor map, right? And we will know the distance between the two of those as we're setting them up. So a typical implementation plan with Apptricity for IPS is that we would go to your location, we would measure the distance of the floor that you're trying to track. Maybe you already have that information, but we would then go to a floor map and say, okay, what would maximize the read accuracy? What configuration of the fixed readers would maximize read accuracy? Because that's what we're going for, right? And so we would then say, okay, well, if we put one, this many feet away from the corner, and then we want things to be equidistant from each other. So that way we're maximizing read coverage. So those are the Bluetooth low energy beacons. That's the fixed readers. And then the final part is we have cloud hosted asset and inventory management software. This is where you would keep any sort of information about your assets and inventory. This is also where you would view your information on the map. So you have the floor map that's displaying everything, but that floor map is within an asset or inventory management system. So those are the components that make up IPS. And the read accuracy, we like to define that in three P's, essentially: presence, proximity, and position. So the three P's: presence, proximity, position. I'm not going to quiz you on it, but it's easy to remember. Three P's. And basically what this means is it's just the different levels of location accuracy that you can get from an IPS system. Presence means I just know it's here, right? So if you look at the image on the left of the slideshow, it just shows the building, right? Maybe presence to you means I just know it's in the building. And we've worked with customers where that's all they need to know. They don't need to know that it's in, rack 2, bin 5. They just need to know that it's in the building. And a system like that does not require as many fixed readers. So one of the things that that an IPS system, one of the components of an IPS system, is you essentially have this scale, right, of read accuracy on one end and cost savings on the other, right? The more readers you put up, the higher the accuracy will be. And there's two components to that. There's the trustworthiness of the data, and there's the accuracy of the read. And so basically, if I have 2 or 3 scanners, I can say with a high level of confidence that it's within this 10-meter range. But as I move down the ranges, I may only be able to say with a low level of confidence that it's within this 3-meter range, right? So we have reliability of the data, confidence in the data, and location accuracy. So basically, the more readers you have, you can say with a higher level of confidence that it's in this smaller area, right? And as I said, the technology is advancing, and it may be before the end of this webinar, we will have achieved less than 3 meters of accuracy, right? That's, we've got smart people working on this right now, but essentially that's the scale. If you want to save, if you want to spend less money, you're going to get less accuracy. And maybe that's where presence comes into play, right? And that may be okay. There's nothing wrong with that, right? If you just want to know that it's in the building, you don't need 100 readers, right? Maybe you only need 5 or 6. And so that's presence. Proximity is now, I know the general region where the item is. So imagine we have a warehouse and we divide it into quadrants. Proximity would be, I know it's in the northwest quadrant. Or maybe it's, I know it's in the southeast quadrant. Again, that may be valuable enough to have that information to be able to go find, because that's really ultimately what this IPS system does, is it gives you in terms of proximity, it gives you the general neighborhood of where it might be. And then you can go visually confirm, yes, I see it, it is here, right? Whatever it is you're trying to track. And so that's proximity. Position is the exact position of the item, right? And again, we talk about read accuracy, 3 meters. If I can get within 3 meters or 9 feet of an item, at that point, I can with a high level of confidence, I can visually confirm, hey, I see it, here it is, right? And that's what we're trying to accomplish, is visibility, right? And then again, as we continue to advance technology and that margin gets smaller, now we're eliminating, the amount of walking around you have to do to go find that item. But typically what we've experienced on the spectrum is people wanting to know, hey, my warehouse has everything that it's supposed to have, presence. But then we have people who are like, I need to know the exact area because I need to go find that and pick it, maybe pick, pack, and ship, right? Or I need to find it because maybe it's about to expire. And so that's where presence really comes in, when you have to go find something quickly and you need to get directly to it. So these accuracy levels, they're driven off of the number of readers that you set up within a building. That's basically the main takeaway here. So how do we set this up? How do we establish a solution? So basically, the first step we would do is we place fixed readers across the floor of the area. Second step would be to associate Bluetooth beacons with the items that you are trying to track. So again, that could be anything. That could be retail, that could be pallets, that could be heavy machinery. It could be anything that you want to track. If you can attach a Bluetooth tag to it, we can track it. Essentially, what you would need to do when you're associating that Bluetooth tag is you are associating the unique value of that Bluetooth tag, which is typically the MAC address, with the specific item that you're tracking. That could be a pallet, that could be, a SKU. If your system already uses barcode for specific items, you could just tie that into barcode as well. But you want to associate the tag with the specific item. The third step would be to upload a floor map. So once again, that could be as simple as a JPEG or PNG. It could be as complex as an AutoCAD architectural drawing. Anywhere between those two extremes, we can support that. Then we would define the fixed reader locations, right? So this is again where we start making that conversion between pixels on the image, or if you're using AutoCAD or GeoJSON, latitude and longitude values, to the actual localized measurement of feet or meters, right? So example, 10 pixels equals 10 feet, right? That may be the calculation for a JPEG or a PNG image. But when you go to GeoJSON and you're using this on the actual map, you're actually using latitude, longitude coordinates instead of XY coordinates. Once that's all set up, you launch the system and you can start viewing that information on the floor map that you uploaded. So once again, in terms of the electricity side of things, on our legacy 7.5 version, you would just go to the floor map. You can set an auto refresh on it, and you'll be able to view the information. If you use our 8.0, our newest system, that system has push mapping, which means you can get those updates as they're happening, right? You don't have to do a refresh. All that information is being pushed to the map, and you can search for your location. You can pull up the map. You can view it all. So that's how you would set up an IPS solution. But why would I want to use this? What are the benefits that really come from this system? We understand how it works. We understand the technology. Why would I use it? The main use case for this system is to reduce shrinkage. If you tag your items, you can reduce time spent looking for items because your system is automatically updating the location of your items as they move. You're not relying on, a warehouse worker or a store employee with their clipboard of, last known location. Well, it moved from here to here. You have a system that's automatically doing that for you. So you don't have to worry about, manual interaction. It's automatically doing that for you. And basically what that does is you don't have to go looking for lost items. You know where that item is, right? And we go back to the presence proximity position, right? You may know it's in the building, or you may know it's in this part of the building, or you may know it's at this exact part of the building. But you don't have to go looking for lost items. If you notice that you're low on stock, you pull up your IPS system, you say, oh, maybe I don't need to order more. There's just these 5 items that are just not where they're supposed to be. Let me go move them back to where they're supposed to be. Right? Or if you've got perishable inventory items, right? You want to know, hey, this thing has an expiration date that's rapidly approaching. If I'm going to go pick and ship an item, I need to go find that thing first so that it doesn't expire. So that's how we reduce shrinkage. Another benefit you get from this is cycle counting, automated cycle counting. Anything that is tagged, if it shows up in a scan, you know it's there. You know in real time what that inventory is. Instead of sending an employee to go scan and say, oh, I found this many of this item. My first job was at a sporting goods store, and when we used to do inventory, it would take us 4 hours, and we had probably 50 employees at the store, and it was I go, I scan a barcode, I visually identify, oh, this is baseball bats, this is baseball gloves. Here's how many we have. We all input it into a system, and it was very error prone. I was 16 years old. It was 2 a.m. I was not the most reliable person to go scan and give inventory counts, right? And so if you can do that with an automated system, it takes away a lot of that error, right? And it's doing it as often as you like. As often as that scan is taking place, I'm getting that information. And that information is being updated in my system. And then we talked a little bit already about pick, pack, and ship. Basically, if I'm in a warehouse and I know I need to pick, pack, and ship specific SKUs off of a pallet, or I need to go pick a particular item, I don't have to spend my time wondering what bin it's at. I can go to my IPS system and say, oh, I know that this SKU is in this location. I can go pick from there, right? So it increases your visibility for pick, pack, and ship. These are just a couple of the solutions for IPS, or a couple of the benefits of an IPS system. There are many more. These are just the 3 that I thought would be most valuable and most relevant to our audience here today. So what's the future of IPS? Because I know we talked a little bit about better location accuracy, how those numbers will continue to shrink. Some of the other benefits that we're going to see here in the future is faster updates for location. So in our system, those location updates are made every 10 minutes because it's a lot of data being sent, right? It's running an algorithm. It's a machine learning algorithm that helps predict the location. That takes time. But as computing power increases, as we fine tune the algorithm, we're going to get that data closer to real time, right? As the processing power, becomes more efficient, it's going to execute that query more. As the machine learns more, this is one of the benefits of machine learning, is the longer it runs, the more efficient it gets, right? We'll be able to execute those queries a lot quicker. We talked about better location accuracy. There's some new technology with Bluetooth 5 that includes angle of arrival and angle of departure. That information is key for location tracking. It helps refine the positioning data. And like we said, fixed readers, if you could put more of them up, you'll get better read accuracy. We're all aware there's supply chain issues right now with components. And so the price of components is probably a little higher than it will be once those issues get sorted out. And so the future of IPS will be cheaper readers, cheaper tags, so that you can provide better location accuracy. And I just hit my 3rd point when I was talking about my 2nd one. So that's really the future of IPS. This is what we can expect to see within the coming years. Like I said, this is a cutting edge technology, or bleeding edge, however you want to define it. But the reason why I like to say cutting edge is because it's fielded, it works, we know it works, and it's a technology that can provide immediate ROI for your business once you install it and you get it running. And the best part is, once you get it running, it's going automatically. You may have to do a little bit of maintenance here and there, but it's few and far between. So that's really the future of IPS. With that in mind, we have arrived at our Q&A session. If you have questions, feel free to type them out in the chat. I'll start to pull the chat up here and just address anything that you may ask about IPS. And we'll do this for about the next 10, 15 minutes, and then we will close up. All right, first question. Do I have to use Bluetooth, or can I use RFID? This is actually a question that we get pretty frequently, because RFID is cheaper than Bluetooth, but you cannot really use passive RFID in the solution, because it is exactly that. It's a passive tag. One of the key components of an IPS system is the fact that the beacon is broadcasting, and it's making its way to the Bluetooth antennas, the Bluetooth readers, as opposed to the readers having to go all the way to scan a passive tag. So the fact that Bluetooth is an active beacon tag is what makes IPS work. If you were to use RFID, you'd have to have too many readers, and it just wouldn't function in the same level of accuracy. So that's why RFID is not really a solution in that regard. Okay, question number 2. What is the size of the beacon? So beacons can range in size, but typically the ones that we've used are maybe 1 inch by 2 inches. No, probably 2 inches by 4 inches. There are ones that are about the size of a quarter, and these have replaceable batteries. There are models that are made with non-replaceable batteries. Those tend to be the cheapest because obviously you can just throw them away when they die. But they can be as big as an ID badge if you wanted to do things like track personnel. But the size of the beacon, pretty small. Think about a quarter to, if you wanted a rectangular tag, it could be anywhere between 2 inches or 4 inches in length and 2 inches in height, or width rather. Okay, question number 3. Can I use IPS for indoor tracking and also use GPS at the same time? Yes, you can. So one of the use cases that we use with Verizon is they want to track things inside the warehouse, but as soon as it leaves the warehouse, they want to rely on GPS tracking. So we can do that. So at Uptricity, we have beacons, Bluetooth beacons with GPS antennas built in. So they can provide GPS data once they leave the inside of a building. You can also put a GPS tag and a Bluetooth tag on an item at the same time. So as soon as it leaves the warehouse or leaves the building, you can switch to GPS tracking as the primary method. All right, number 4, question from Todd. We would like to track location of zebra scanner devices. How large are the tags, and is that a common use case? So we talked a little bit about the tags already. Like I said, it was about the size of a quarter to, I know that it's I'm pretty small on the camera, but if you can see that well, it's not very big, right? They're incredibly small, low profile. Tracking zebra scanner devices. What I would say in terms of how common is that use case is that we can track anything. If you can put a tag on it, you can track it. Now, some of those zebra scanning devices, if it's the one that I'm thinking of, and Todd, you can correct me if I'm wrong. If you're talking about the handheld scanners, then okay, I see you nodding. Awesome. Yes, you can track those with a Bluetooth tag. They're very small. You would just affix it onto the scanner itself, and then as those scanners move around, you can see where they're at. It's not a use case that we've done before, but it is absolutely something that's doable. Okay, question 5 from Susan. Are Bluetooth tags recyclable? I kind of touched on that a little bit. The tags that have chargeable batteries or replaceable batteries, I would say that those are recyclable. Now, we talked about this in the previous webinar, but when it comes to Bluetooth, you can configure the ping rate, so how frequently it broadcasts, at the expense of battery life. So the less frequently it pings, the longer it will last, right? If you want more real-time data, you may want it to ping every second or every 2 seconds. You're going to drain battery quicker, but at the same time, you're getting more information as it goes. So when it comes to recyclability, say I'm in a warehouse and I tag, let's say I tag a piece of heavy machinery that I just sold, right? Once that thing goes out the dock door, you can take that tag off and then reassociate that tag with a different item at that point. So as long as there's still battery life, and there's battery notifications as these tags start to die, as long as there's still battery life, yes, you can recycle them. For the tags that don't have replaceable batteries, like I said, they can be the cheapest, but once they die, they're pretty much useless. So you would just toss those. Question from Annie. Is real-time location tracking possible with IPS? So real-time tracking is a bit of a quandary. I think a lot of people say, okay, we do real-time tracking. Well, real-time would mean every second it's being updated, right? So basically what we would call our IPS system is near real-time currently, where the location information is updating every 10 minutes. So basically, behind the scenes, how IPS works, without getting too technical, is that you would have the cloud-hosted asset or inventory management server, running, or it would be hosted in the cloud, so it wouldn't be a server. But we would then have our IPS service running, It's processing all the scan data. It's using machine learning. And it's then communicating that information, that location information, to the cloud, right? And then that's how it's updating the location. That process takes time. Like I said, we're constantly refining. The longer the machine learning runs, it gets quicker as it goes. That will continue to get closer to real time, but currently we would refer to that as near real time. And again, there's factors of how often the tag pings. If it pings more frequently, you get closer to real time. If it pings less frequently, you get further away. So that's how real time and near real time works. Question from Todd. Are the beacons attached to the asset, or is that between the asset and the readers? The beacons are attached directly to the asset. So basically the readers are set up at various points, various structural points on the floor. The tags themselves are on the asset. So that's why you would make that association between whatever the unique identifier is of that asset and the MAC address of that tag. You marry those two, so that way, as it moves around, you know that this asset, the specific asset, is moving around and it's now at this specific location. Another good question. Had some good questions here today. Well, I think if there are no other questions, we can go ahead and close up for today. I'll just kind of close by doing a couple things. Number one, I want to thank you guys for tuning in. If you want a copy of this, like I said, reach out to Susan. She'll be able to get you one. We'll also be posting this on our YouTube channel. You'll also be able to see the first webinar on the YouTube channel as well. Looking ahead, the next webinar is in 2 weeks. It's at the same time. Susan should have a link for that if you want to sign up. We'll be using the same Zoom format. I'm going to be hosting all 4 of these. And so for the next webinar, we're going to be doing an industry highlight for IPS. And so what we would ask from you, the audience, is tell us a little bit about your business. Tell us about the industry that you're in, and we can give you a little bit more of a pointed webinar on how we can help that industry. IPS can be used in a variety of places. I've seen it used in healthcare, retail, manufacturing, a lot of different areas, right? There's more than just the 3 that I mentioned. And so what we want to do is really tailor this 3rd webinar to understanding your business so that you can see in a more specific way how IPS can help your solution. So that's really going to be the content for the next webinar. We'll be focusing on 2 or 3 industries. If we don't get any feedback, I have a number of industries that I know that we want to focus on, just based off of what we've seen in the industry. So no pressure to reach out to us if you don't want to share. But we are looking to tailor this to you, the audience's specific use case. So that's going to be the content of the next webinar. That will be in 2 weeks at the same time. In the meantime, if you have any questions, if you want to learn more, if you want to see this thing in action, reach out to Susan, reach out to myself. We'd be happy to schedule a demo on the electricity side and how we can help your business out. That's really it from my end today. So again, thank you guys for tuning in. Hopefully we'll see you in 2 weeks' time, and stay safe. We'll see you soon.